Hello, ladies and gentlemen. Today we're going to learn about trigonometric identities, one of my favorite things in trigonometry. An equation is an identity if the left side is equal to the right side for all values of the variable for which both sides are defined. And we're going to start with some reciprocal identities. All right, and the reciprocal of the sine of theta is, of course, 1 divided by the cosecant of theta. All right. The reciprocal of the cosine is 1 divided by the, the secant of theta. And the reciprocal of the tangent is the reciprocal of the cotangent of theta. All right. Likewise, if you reciprocate each side over here, all right, you would get here. This would be 1. The reciprocal of the cosecant is the 1 over the sine of theta, and the reciprocal of the secant, or the secant of theta, is 1 over the cosine of theta. And of course, the reciprocal of the cotangent is equal to the reciprocal of the tangent of theta. All right. Now, we also have the fact that tangent can be expressed as sine over sine of theta divided by the cosine of theta, and that's probably the better way to write that. That's one of what's called the quotient identities. And if you reciprocate each side, you would get that the cotangent of theta is the cosine of theta divided by the sine of theta. All right, now let's go talk about the Pythagorean identities. All right, we will start with the most famous one of all, and that is that the sine squared of theta plus the cosine squared of theta is equal to 1. And from that particular one, you could, and I'm going to do this, you could solve it for each of its 3 terms. Right now it's solved for 1 because 1's by itself. I could solve it for the sine of theta by subtracting the cosine of theta on each side. If I did, I'd have the sine squared of theta on the left is equal to 1 minus the cosine squared of theta on the right. So that's another identity that you should know. All right, we could have also solved it for the cosine of theta, which cosine squared of theta, which would have said the cosine squared of theta is equal to 1 minus the sine squared of theta. All right. The next Pythagorean identity is that the tangent squared of theta plus 1 is equal to the secant squared of theta. All right, and we could solve that for the tangent squared of theta if you wanted to. You would have the tangent squared of theta is equal to the secant squared of theta minus 1, or you could solve it for 1 and say that 1, and I'm going to put the word or here, 1 is equal to the secant squared of theta minus the tangent squared of theta. All right, and now the next one, Pythagorean identity, says that the cotangent squared of theta plus 1 is equal to the cosecant squared of theta. And of course, you could solve that for the cotangent squared of theta if you wanted to. All right, just simply subtract 1 from each side would give you the cotangent squared of theta is equal to the cosecant squared of theta minus 1. Or if you solved it for 1 would be equal to the cosecant squared of theta minus the cotangent squared of theta. You should be able to take any one of these and solve it for the other. All right, let's turn the page. Next, we're going to look at the cofunction identities. A trigonometric function f is a cofunction of another trigonometric function g if f of alpha is equal to g of beta, where when alpha and beta are complementary angles. All right, so the sine of theta is equal to the cosine of theta of pi over 2 minus theta. All right, the cosecant of theta is equal to the secant of pi over 2 minus theta. The tangent of theta would be equal to the cotangent pi over 2 minus theta. All right, the cosine of theta would be the sine of pi over 2 minus theta. the secant of theta would be equal to the cosecant of pi over 2 minus theta, and the cotangent of theta would be equal to the tangent of pi over 2 minus theta. All right, and these are identities that you need to memorize, all right? We also have the odd and even identities, and they say that the sine of negative theta is the opposite of the sine of theta. The cosine of negative theta is equal to the cosine of theta. The tangent of negative theta is the opposite of the tangent of theta. The cosecant of negative theta is the opposite of the cosecant of theta. The secant of negative theta is equal to the secant of theta. And the cotangent of negative theta is equal to the negative, or the opposite of the cotangent of theta. Just please remember those. We're going to use them throughout the rest of the year. Okay. All right. Turn the page and we'll start with our examples. Example number 1 says, if the cosecant of theta is 7/4, find the sine of theta. Well, the cosecant is 1 over the sine of theta, all right? So that means that you can replace the cosecant of theta with 1 over the sine of theta, all right? And if you do that, and then you reciprocate both sides, on the left, you get the sine of theta, which is what we're looking for. On the right, you get 4/7. And that means we're finished. We found the sine of theta, which is 4/7. All right, so we're done. Let's go to number 2. In number 2, it says, if the cosecant of x is 7/3 and the cotangent of x is 2 times the square root of 10 over 3, find the secant of x. Okay, well, let's start with the, with the cosecant. That is also the reciprocal of the sine, all right? And that means that if you were to write 1 over the sine of x is equal to 7/3, you would know immediately that the sine of x is equal to 3/7, all right? Now, we also know that the cotangent, which, by the way, is the cosine over the sine, so the cosine of x over the sine of x is equal to 2 times square root 10 divided by 3. All right. Well, we happen to know that the sine of x, all right, is 3/7. Okay, so we would have the cosine of x over 3/7 is equal to 2 times the square root of 10 over 3. All right, and now let's multiply both sides by 3/7. Okay, so we'll multiply both sides by 3/7. All right, and that means these would cancel, giving us the cosine of x is equal to, those 3's would cancel, 2 times the square root of 10 over 7. All right, now we're looking for the secant. Well, the secant is the reciprocal of the cosine. So 1 over the cosine of x, which, by the way, is the secant of x, is equal to 7 over, because we're just reciprocating this side and that side, 7 over 2 times the square root of 10. All right. And now we'll simplify that radical by multiplying both the denominator and the numerator by the square root of 10. And that would tell us that the secant of x is equal to 7 times the square root of 10 divided by 20. All right? And that is your secant of x. You're finished. Let's go to number 3. In number 3, all right, it says, if the tangent of theta is -8 and the sine of theta is greater than 0, find the sine and the cosine. All right. Well, I want to sketch this graph. I want to put this angle because I don't think this is on the unit circle. I don't know any -8's on the unit circle, so I'm going to sketch it. The tangent is negative in the second and in the fourth quadrant, but if the sine's positive, that places that angle over there in the second quadrant. I'm going to drop a perpendicular so that I can get a right angle, and I'm going to put theta here. All right, now, I know the tangent. Well, the tangent is the opposite leg, which would be 8, divided by the adjacent leg, which is -1, if you like, or 1. And now, if I did the Pythagorean theorem, I would get this hypotenuse to be the 64 plus the square root of 64 plus 1, which is the square root of 65, using the Pythagorean theorem. Okay, so now what I want next is the sine of theta. So the sine of theta is opposite 8 divided by the adjacent, the square root of 65. Now, sine's a y. Is that y coordinate positive over there in that second quadrant up in there? And the answer is yes. But I would definitely need to simplify this. All right, if I do, by multiplying the numerator and the denominator by the square root of 65, 8 times the square root of 65 would be my numerator, and 65 would be my denominator. So there's the sine of theta. I now need to find the cosine of theta. Well, the cosine's negative over here because that's the x-coordinate. So the cosine of theta is negative, all right? And the cosine is the adjacent leg, 1, divided by the hypotenuse, the square root of 65. Now, of course, I can simplify that, all right, by multiplying the numerator and the denominator by the square root of 65. When I do, I get negative the square root of 65 for the numerator and 65 for the denominator. And there's the simplified version of the cosine of theta with the given information. All right, let's turn the page. Okay, on the next part here it says, if the tangent of theta is 1.28, all right, find the cotangent of theta minus pi over 2. Okay, well, this looks like one of our cofunction identities, okay? All right, it looks like, let's see, one with the it looks like this one right here, with the one exception, okay? All right, this one has got these two terms, the opposite of these two terms are set here. So what I'm going to do is I'm going to take that, excuse me, I'm going to rewrite this as the cotangent of, I'm going to factor out that negative, and then I'm going to, inside, I would have pi over 2 minus theta, all right? And now I've got the cotangent of the opposite of an angle. Well, that's an odd and even identity. That's one of those odd and even identities. Let me pull that one back up for you, okay? The cotangent of negative an angle, okay? The cotangent of negative theta, right here it is negative cotangent of theta. So that would be equal to negative cotangent of pi over 2 minus theta. Now we can use one of those cofunction identities to simplify, forget the negative part for a moment, just the cotangent of pi over 2 minus theta. Well, the cotangent of pi over 2 minus theta is just the tangent of theta. So this would be equal to negative the tangent of theta. And we know the tangent of theta is 1.28, so this would then end up being, okay, equal to the opposite of 1.28, which is negative 1.28. All right, so there's your work for that one. Okay, let's go to number 5. Number 5 says to simplify the cosecant of theta times the secant of theta minus the cotangent of theta. Well, each of those are reciprocal functions, so I'm going to use the reciprocal function identities and rewrite the cosine or cosecant of theta as 1 over the sine of theta times, I'm going to rewrite the secant of theta as 1 over the cosine of theta minus, and then I'm going to rewrite the cotangent of theta as the cosine of theta divided by the sine of theta. Okay, all right, so now the left-hand side can become 1 over the sine of theta times the cosine of theta minus the cosine of theta divided by the sine of theta. I want to combine these two fractions into one is what I want to do, which means I need a common denominator. The common denominator would be the sine of theta times the cosine of theta, and this left-hand fraction already has that. So I'm going to leave that alone for a moment. All right, minus. And now I'm going to multiply both the numerator and the denominator by the cosine. So up top, I would get the cosine of theta, and down below, I would get the sine of theta times the cosine of theta. And now I can combine these, oops, wait a minute, hold on. There was already a cosine up there. It should be cosine squared of theta. All right, and now I can combine these two fractions into one. My numerator would be 1 minus the cosine squared of theta. My denominator would be the sine of theta times the cosine of theta. And now, anytime you see 1 minus either the sine squared of theta or the cosine squared of theta, you should know that that's equal to either the sine squared of theta or the cosine of theta squared of theta, and this one is the sine. So this, I'm going to bring this up here, that numerator is simply the sine squared of theta divided by the sine of theta times the cosine of theta. Well, now I have a common factor among the numerator and the denominator. That common factor would be the sine of theta. So if I divide both of them by the sine of theta, and I'm talking about the numerator and the denominator, up top I get the sine of theta. This sine of theta and that sine of theta would cancel, which is the cosine of theta. And the sine of theta divided by the cosine of theta is simply the tangent of theta. So that's all the same thing as the tangent of theta. Okay, let's go to number 6. In number 6, we are asked to simplify, all right, the sine squared of x times the cosine of x minus the sine of pi over 2 minus x. Okay. Well, I know this is a cofunction identity, okay? All right, so I'm going to use my cofunction identity, and I'm going to replace that with, and if you're unsure, you can always refresh back real quick since you may not have that memorized, the sine of pi over 2 minus x. Oh, that's just the cosine of x, is what that is. So that's the cosine of x. All right. Now, when I look at those two terms in this example, I notice that those two terms have a common factor, all right? The common factor is the cosine of x. So I'm going to factor the cosine of x out, all right? What's left is the sine squared of x minus 1, okay? All right, and the sine squared of x minus 1, sine squared of x minus 1, oh, wait a minute, that looks like, okay, oh, yes, that's the opposite of the cosine squared of x, okay? Because if you go back and look, let me go back for just a moment, that inside is the opposite of this expression right here. If you take the opposite of this expression, you would get the sine squared of x minus 1. And that's the opposite of the cosine squared of x, okay? All right, so the cosine of x times the opposite of the cosine squared of x is what we're looking at here, okay? All right, and then when we multiply these, we would get the opposite of the cosine cube of x. All right, so there's what we get when we simplify number 6. Let's go to number 7. All right, number 7 gives you the expression the sine of x times the cosine of x divided by 1 minus the sine of x minus 1 plus the sine of x divided by the cosine of x. Well, I want to combine those two fractions into one, all right? And that means I need a common denominator. Well, the common denominator would have to be the product of these two denominators. So I'm going to multiply this numerator and this denominator by that denominator, the cosine of x, all right? And then I'm going to multiply this numerator and this denominator by that denominator, 1 minus the sine of x, all right? 1 minus the sine of x. And that will give me two fractions with the same denominator, okay? And that denominator will just be the cosine of x times 1 minus the sine of x. And there's no need to write that down twice, so I'm just going to write it down once. If you want to write it down twice, please feel free. I'm not going to do it because I know that I combine these two fractions into one, and that common denominator is going to be cosine of x times 1 minus the sine of x. Okay. All right. Well, up top, I need to do this times this, which would be the sine of x times the cosine of x squared, minus, up here, when I do this product, I get 1. The outer product is negative sine of x, and that's an x. The inner product is positive sine of x. Those would cancel, all right? And then the product of the last terms would be minus, whoops, I'm going to put that 1 minus the sine squared of x. All right. So now I can do, for my numerator, I'm going to distribute that negative for a second. The sine of x times the cosine squared of x minus 1 plus the sine squared of x, all divided by the cosine of x times 1 minus the sine of x. All right. Then I'm looking at that numerator up there, okay? All right, and, okay, this 1 right here could be replaced with the sine squared of x minus the, I'm going to replace that, sine squared of x plus the cosine squared of x. So I'm going to do that. Oops, I need an n here. The sine of x times the cosine squared of x minus the sine of x squared plus the cosine squared of x, all right, plus the sine squared of x, all divided by the cosine of x times 1 minus the sine of x. And now I'm going to distribute. When I do, I'm going to get the sine of x times the cosine squared of x minus the sine squared of x minus the cosine squared of x plus the sine squared of x, all divided by the cosine of x times 1 minus the sine of x. All right. Now, up top, these are going to cancel, all right? And what's left is the sine of x times the cosine squared of x minus the cosine squared of x. And if you notice, the cosine squared of x is the common factor, so I'm going to factor that out of each of those two terms in that numerator. So the cosine squared of x times, this would just be the sine of x, minus 1 over here, all right, divided by the cosine of x times 1 minus the sine of x. Well, if you look at these two, they are opposites, okay? If you change the sign on this one, you'll get that one. Or if you change the sign on that one, you'd get this one. And if you divide opposites, that's negative, all right? Negative 1 to be precise. So that's negative 1, all right? So I'm going to put that negative. And over here, the cosine squared of x divided by the cosine of x is just the cosine of x. All right, so that's simplified to negative the cosine of x. All right. Example number 8 says, rewrite 1 divided by 1 plus the cosine of x as an expression that does not contain a fraction, okay? Well, one of the things you might want to try when you have a fraction and you don't want a fraction is to multiply the numerator and the denominator by the conjugate. And the conjugate, is, if it's a sum, would be the difference of the same two quantities. Or if it's a difference, it'd be the or if it's a sum, it'd be the difference. If it's a difference, it'd be the sum. Well, this denominator is a sum, so I'm going to multiply the numerator, all right, and the denominator by the conjugate of this denominator. And the conjugate of 1 plus the cosine of x is 1 minus the cosine of x. This is a little technique that we use a lot. Okay, all right. When I do, up top, I get 1 minus the cosine of x. Down below, my first, this is like a binomial times a binomial. The product of the first terms is 1. The outer product is negative cosine of x. The inner product is positive cosine of x. Those will cancel. And the product of the last terms is negative, all right, cosine squared of x. My fault, that's a C. Cosine squared of x. All right, so now I notice that I've got 1 minus the cosine squared of x. Well, I immediately know that that is equal to the sine squared of x. All right. And now what I'm going to do next is I'm going to separate this into two fractions. I'm going to say one, and this is something you need to always remember is this. If you have a plus or minus b over c, that's a over c plus or minus b over c. And that's the little algebraic rule I'm going to use right here because I've got a difference up top divided by a monomial down below. I'm going to take 1 over the sine squared of x, and I'm going to subtract from that the cosine of x divided by the sine squared of x. Okay, all right. Now, I know that 1 over the sine squared of x is simply the cosecant squared of x, all right? And what I'm going to do next is this. I'm going to, and I've got a subtraction, I'm going to once again separate this a little bit into the product of two fractions. I'm going to do 1 over the sine of x, and then the cosine of x over the sine of x. Because if I multiply this times this, I get that numerator, and this sine of x times sine of x is sine of x squared. Okay, so this would be equal to the cosecant squared of x. Now, each of these are either a reciprocal function or a quotient function. This is a reciprocal. The reciprocal of the sine is the cosecant of x, and this is the quotient function, which is the cotangent of x. All right, and now my expression does not have any fractions, and I'm finished. All right, if you have trouble doing any of your work, please get back in touch with me either through email, Google Meet, or call me, whatever you need to do. Have a good day. Thank you. Bye.